For government customers that have some of them with like super critical mission workloads, these customers need that capacity there guaranteed when they want to launch it. And this provides a mechanism for that to actually happen.
Today, we're going to talk about managing your use of capacity inside AWS with Parallel Cluster. We're going to talk about ODCRs, reserved instances, savings plans, multi-AZ configurations. We're going to cover quite the full gamut, but it's all focused on how you actually manage your use of capacity and how you corral that capacity for your workload. Elasticity be damned, sometimes you actually need a fixed amount of capacity for a specific amount of time to get a workload done in the cloud in a guaranteed way. How do customers go about doing that?
So there's two ways to do it, really. One, you could just set up you could set your queue architecture up to have a minimum and maximum of 64 nodes. And then it's not an elastic cluster anymore. But the other thing that you can do is, and this is good if you have this fixed demand, but it's still kind of punctuated. Maybe you only need to run this fixed workload on Wednesdays and Thursdays. Or maybe you only need it for a month at a time, but you really need it when you need it. To support that, Parallel Cluster supports something in Amazon and AWS called on-demand capacity reservations and reserved instances. Basically, you can use what's called an open ODCR. ODCR is short for on-demand capacity reservation. I'm not going to say that every single time. A targeted ODCR, and even groups of reservations together called reservation groups with Parallel Cluster. And if you've purchased reserved instances, those can be automatically applied to your reservations. So like what you might do is you might set up a targeted ODCR, then update your queue or your node group to point to it. And then the new instances that get launched will be drawn from that reservation until it's exhausted. This is kind of an advanced topic. So we've got a bunch of documentation in the Parallel Cluster user guide, and there's even a blog about it.
Yeah, and Matt, I'll say for government customers that have some of them with like super critical mission workloads, they leverage ODCRs and zonal reserved instances specifically. These customers need that capacity there guaranteed when they want to launch it, and this provides a mechanism for that to actually happen. You mentioned mixing instance types, right? That could be helpful for pulling together capacity for really heavy workloads. Are there ways to use instances from maybe other availability zones from the primary one that I'm currently working in?
Absolutely. So like generally, it's good to do most of your work in a single availability zone. Kind of you can conceptually think of an availability zone as a data center. That's not quite true, but that's basically how you can think about it. So as long as all of your work is in one region, you can do this. And here's how it works. When you configure one of these node groups in a queue, by default, you set up a subnet that's in one of your availability zones that your instances are going to launch in. But if you've got other subnets in the same VPC, but in other availability zones, you just add those to the node group. And new instances will be launched kind of randomly in those other designated availability zones. It's just kind of round robin load balances for you. And that's it. And if you don't want to do that anymore, you just take those node groups away from the configuration, and it'll go back to your primary availability zone.
Right, but you got to be careful here. If you've got a workload that's using tightly coupled communications, like in other words, something like say a fluid dynamics job or a structures code, you need to remember that EFA, our elastic fabric adapter that makes all of those codes scale really well in the cloud, does not work well. In fact, it doesn't work at all across availability zones. And that's deliberate because, those availability zones are miles and miles apart from each other by design. You don't want tightly coupled codes trying to do their communications across tens of miles. That's bad. The curvature of the Earth becomes really quite a gating factor as to how fast those codes are going to work at that point.
Yeah, and that also applies for shared storage as well. You might have some workloads running in one AZ, but your actual file system access points are available in another availability zone, and number one, that could add latency, but two, there's costs associated with that. And there are videos on this, parallel cluster multi-AZ videos, where you can learn details and get suggestions for best practices for these scenarios where you might have to leverage another availability zone for your workloads.
Yeah, I would also add this is a great time to talk to a solution architect. When you start advancing into some of these really advanced deployment configurations, it's good, especially if you're new to HPC in the cloud, new to parallel cluster. This is a great time to talk to somebody who has probably built similar solutions before.
If you're enjoying these videos, please give us a like and consider subscribing to the channel so that we can keep making more to help you understand how the cloud works and to show you new ways to help all the scientists and engineers around you who use HPC every day to do amazing things. It's what gets us motivated as well. See you next time.